Hi, I'm Selvakumar. I've got years of experience in IT. I want to talk about Apache Spark, the computational framework for big data analysis. In this session, I'm going to cover all these topics. That is the need of Spark, the need of Apache Spark. Actually, we have already got Hadoop, and it has been here around 10 years. Then why do we need a new technology like Apache Spark? That we are going to discuss. Then we are going to analyze, or we are going to compare the two technologies between MapReduce and the Spark. Both are the computational framework for big data analysis. So we can analyze these two technologies, and we can come out with the pros and cons of these two technologies. Then that will be followed by the architecture of Spark. Architecture of Spark, there are three components: data storage and the resource manager and the API. That will be covered in this architecture of Spark. Then RDD. RDD is a resilient distributed dataset. This is the core concept of Apache Spark. I mean, the data is stored as RDD, partition to RDD. This is a logical collection of data in Spark. Hence, we need to have a little bit deeper knowledge on RDD. Then, some of the features we are going to discuss on Spark, followed by the RDD. Then, components. I mean, the next one is the components. It covers the driver program, cluster manager, and the data storage, everything in the components. That will be followed by an example. The example we are going to discuss is the word count, that is the hello program for big data analysis. Through this word count example, we could also discuss a little bit about narrow dependency and wide dependency. Now we can see why do we need Spark. Actually, we have got Hadoop that is available for more than 10 years, and there are a number of ecosystems that have been developed around Hadoop, and many organizations, big, small or medium, many organizations, they have already implemented Hadoop applications. There are tools available for for developing the Hadoop applications in a easy manner. Then, and the MapReduce is the computational framework, and that is also familiar for all the people. Then why do we need a new technology like Apache Spark? For which we have to consider the MapReduce, the computational framework of Hadoop. It is very good and one-time pass of the data. I mean, the data can be processed one time, and the result will be stored in the disk. But it is not suitable for multiple time processing of the data. That kind of multiple processing of data is required for machine learning. So it doesn't support machine learning. So for machine learning, they had to develop a new system, a framework. That is where the Apache Spark comes. So when the Apache Spark, it stores the resultant data set in the memory, not in the disk. So that means if the data is stored in the memories of the clusters, then we can do multiple processing of the same data. So, and that is the requirement of the machine learning. So Spark is developed for machine learning, but it also give another one capability for us, that is the interactive processing. That's the reason the Apache Spark has been evolved. And let us compare the MapReduce and the Spark. For which, while comparing these two technologies, we can consider 5 categories. One is performance, second one is ease of use, third one is real-time processing, and fourth one is the fault tolerance and ease of maintenance, by which we can understand what is the pros and cons and where we can use these kind of technologies likewise. So for performance, to understand performance, we need to understand performance. First, we have to understand the MapReduce, how it is working. MapReduce have two phases. One is mapper and another one is reducer. That is, the mapper is meant for transforming and filtering the data, and the reducer would aggregate those data. That is the way it is working. And for a simple use case, we can have one MapReduce. That is, one mapper and one reducer. One MapReduce we can have for a single use case. It contains one mapper and a reducer, and that provides the results for the solution for that particular use case. When it is one, no issue. But we know that our use cases in big data is very complex. For complex use cases, we need to chain together a multiple MapReduce. That is MapReduce 2, MapReduce 3, likewise. So what happens when the data is processed in MapReduce 1? MapReduce 1 is stores the data in memory, in disk. So it will be the input for the next MapReduce. So for which this MapReduce needs to take the data from disk to memory. Likewise, it will also store its results in the disk. Then the next MapReduce needs to take the data from disk to the memory. Likewise, it is getting processed. So when you put together a tens of or hundreds of MapReduce processes, because of the I/O processing, that means processing, transferring the data from between disk and memory, and the streaming, replication, other factors. These factors makes MapReduce to be working very slowly compared to Spark. But in case of Spark, what happens is, when we have a number of processes, it may be mapper or have a number of processes that are putting together, likewise, then once the data is processed by process 1, it will be stored in the memory, not in the disk. So the next process would take the data from this memory. It will store the result in the memory. The next one would take the result from there. So this is the way the Apache Spark is working. Because of this, the Apache Spark is several times faster than MapReduce. So performance wise, Apache Spark is several times faster than the MapReduce. Then we can go to ease of use, the nested category. In this use of use, let us assume there is only one MapReduce. It has two classes. One is mapper class and a reducer class and a driver class also. To combine all this, it provides details about the job that is to be submitted. So when we have a single MapReduce, we need three classes. All these three classes would put together around 20 lines. So when we have tens or hundreds of MapReduces, the number of lines will become too large. That means it may be 200, 400 lines of the code. So in that case, in case of Spark, what we have is, instead of for a single process, instead of having 20 lines, we can reduce it 3 or 4 lines by using the Scala programming. So the size of the program, the size of the code will be reduced. When it is put together a number of Spark program, the size of the program will be reduced tremendously. So what is the problem with increasing size of the code? Everyone, we know that the development will become complex. The debugging becomes complex, and the maintenance of code also becomes complex. Development, we know that we have to write a number of lines instead of, we have to write hundreds of lines instead of tens of lines. And for debugging, if any error comes, we have to analyze where the error comes and how to stop it, how to arrest it. All those will become difficult when the number of lines is too large, too high, and maintenance of the code. For example, when someone has written the code and I have to go through the code and maintain it, for determining the functionality of the code, I have to spend a lot of time to understand what is the functionality that would be implemented by that code, because it is too long. But if it is a short one and it is a very descriptive one, then I can easily understand, and the maintenance of the code would be very easy. So in ease of use also, because by using Spark we can reduce development time, debugging time, and maintenance of the code. Hence Spark would be very best for in case of ease of use. The real-time processing, and we know that MapReduce, it stores the data. If we have MapReduce, then it stores the data in the disk. So MapReduce is very good at batch processing, but for real-time processing, it doesn't have any support. It doesn't support us for real-time processing. The reason is, once the data is processed, it would be stored in the disk. But in case of Spark, when we put together a cluster of servers, then the result would be available in the memory. In the memory itself. So data is available in the memory. So what we could do is, the user can apply any query and gets the result immediately. So this kind of real-time processing is possible with the Spark. Real-time processing, MapReduce doesn't support. So for real-time processing also, the Spark has Spark has a capability. In case of fault tolerance, both MapReduce and Spark both supports fault tolerance. First, we know the reason for the fault tolerance. When the Hadoop was being designed, it was one of the important assumptions that the servers in the cluster might get failure during the execution. The reason is, the servers in the clusters are commodity servers. For reducing the cost of the cluster, we were going to use the commodity servers. So in that case, when the cluster contains a number of servers, commodity servers, there is a possibility one of the servers would get failure during the execution of the data processing. So Hadoop avoid this one by applying the factor replicating the data. That is, Hadoop stores data as data block. We know that data block. The size of the data, the default size of the data block is 64 MB, and we can use up to 128 MB. So when we give a file, input file, that file would be split into data blocks, and the data blocks would be stored across the servers in the cluster. When it stores the data blocks, if the replication factor is 3, that is the default value. If the replication factor is 3, every data block would be stored 3 times, and in different servers, not in the same type of server. So the data blocks, every data block will be stored in 3 places. If during the processing, if any one server get failure, so what the MapReduce framework would do is, it finds the replicas of the data blocks that were already available in this server, and it starts a process from that place, the data available as a replication, by which it avoids the fault tolerance and the process will be completed even though the server has failure. In case of Spark, the fault tolerance is also provided, but in a different manner. Actually, the data is stored as a RDD in Spark. The RDD is resilient distributed dataset. It can be created in 2 ways. That is, if you have a external storage like HDFS, HBase, or Cassandra, or Amazon S3, then when you are applying a transformation operation, then it produces one RDD. And this is one way of producing the RDD. And another one way of creating RDD is when you are applying another one transformation operation to the existing RDD, then you can produce a new RDD. This is the way, there are two ways we can create the RDD. One is by applying the transformation operation on the existing storage, or another one way is by applying the transformation operation on the existing RDD. These are the two ways we can create the RDDs. Here, when the RDD is being created, a log would be produced. That is, a queries level log would be produced. So, if any RDD failure during the process, the RDD knows how to recompute and recreate itself from the previous RDD. So, by which it is providing the fault tolerance. However, MapReduce has a high fault tolerance than Spark. The reason is because it is providing the fault tolerance with the help of hardware drivers. So that is the reason MapReduce gives more tolerance than Spark. In case of ease of maintenance, streaming, batching, and machine learning, machine learning. All this will be supported by Spark in the same cluster. That is, in the same cluster, the Spark supports all this processing. But in case of MapReduce, for streaming, we need, MapReduce is better, very good at batching. But for streaming, we need to incorporate another one platform like Stove or Impala. For machine learning, the MapReduce needs to use Apache Mahood. So, for all these complexities, a different data setup needs to be done in the infrastructure level. But in case of Spark, streaming, batching, machine learning, everything would be carried out by Spark itself. The maintenance of infrastructure is very easy in case of Spark, and now it is easy for the organization to simplify the infrastructure implementation with the use of Spark. So for ease of maintenance, Spark has advantage over than MapReduce. Let us talk about Spark API in our next video. Thank you.